Okay, right. We'll start the class. In yesterday's class, I have explained gravitation synopsis and only few problems we have solved in it. In this session, I am going to complete the numericals from the gravitation, as well as I'm going to start that next chapter, mechanical properties of fluids. Mechanical properties of solids completed, we go for mechanical properties of fluids. See, in this problem, it is given two planets are there. Two planets are there whose radius, their radii are given R1 and R2. If the acceleration due to gravity on these planets is G1 and G2, then the relation between R1 and R2 they have asked. Actually, acceleration due to gravity small g is equal to Gm by R square. Small g is equal to Gm divided by R square. It is in terms of mass. We have to say that in terms of mass. In terms of mass, it is. Then acceleration due to gravity, g is equal to 4/3 pi r, 4/3 pi r, g into rho. This is in terms of the density. In terms of densities. So in terms of density, acceleration due to gravity is directly proportional to radius. Therefore, we'll write G1 by G2 is equal to R1 divided by R2. See, in terms of density, same average density, they told that. Two planets have the same average density. That's why we have to take the relation between the small g and the r. Acceleration due to gravity and radius of the planet is g proportional to r. This is in terms of density. This is a rho for density. So G1 by G2 is equal to R1 by R2. A option is correct. So here I didn't remove that. For next classes, I'll remove this option, which is the correct option. I already kept it. That I won't keep for the next classes. Right. An iron ball and wooden ball of the same radius are released from a height h in vacuum. The time taken by them to reach the ground is, they'll reach same time, exactly equal time they will reach. Because here acceleration due to gravity is independent on mass of the body. Acceleration due to gravity is independent on mass of the body. It depends upon the mass of the planet and the radius of the planet. That's why in the equal time they will fall down. In vacuum, no other forces works except gravity. So time period will be exactly equal, that we have tried. Check this. Next. A body of 700 gram weight. A body of 700 gram weight is there on the surface of the earth. On the surface of the earth, a body of 700 gram weight is there. How much will it weight on the surface of the planet whose mass is 1/7 of and radius is half of the earth? See what is given. Mass is weight is 700 gram weight on the surface of the earth. How much it will weight on the surface of the planet whose mass is 1/7 of the mass of the earth and whose radius is half of the radius of the earth? That we have to take. when we take two different G for Earth, G is equal to Gm divided by R, and G planet, on the planet, what is that mass of the planet is taken as? Mass of the planet is 1/7 of mass of the Earth, mass of the Earth, and radius of the planet is half of RE divided by 2. Then we have to calculate what is the acceleration due to gravity on it. Acceleration due to gravity, G is equal to, G is proportional to mass of the planet as well as radius of the planet. Square of that radius of the planet will take that. GMV divided by RE square. Then weight of the planet, we have to take that. Weight of the body on the planet. Weight of the body is nothing. First, we will calculate acceleration due to gravity. Acceleration due to gravity, if you multiply with mass, it will be weight. So, acceleration due to gravity, if we calculate, it's enough. So, then acceleration due to gravity on the planet. Acceleration due to on the planet is GMP divided by RP square. Therefore, GP is equal to G into mass of the planet is 1/7 of mass of the Earth. 1/7 of mass of the Earth divided by radius of the planet. Divided by radius of the planet, how much? RE square divided by 4 it is. Right? Let us suppose this is RE square by 4. So on writing reciprocal, GP is equal to 4/7 GME divided by RE square. This is. So we have to calculate acceleration due to gravity on the planet. GP by G. This is, let us suppose, equation number 2. It is taken as equation number 1. Equation number 1 divided by equation number 2. 4 divided by 7. 4 divided by 7 GME divided by RE square whole divided by GME divided by RE square. Both the numerator and denominator GME RE square will get cancelled. GMA RE square is there. Then GP divided by G is equal to 4 divided by 7. This we have to take weight. Weight is the product of mass. So then weight mg dash, mgp, mg like that. So weight of the body on the planet, m into gp will be taken as weight of the body on the planet is equal to 4/7 into weight of the body on the earth it is. Weight of the body on the earth. Both numerator and denominator I have multiplied with mass. Then I'll get weight of the body on the planet. MGE means what? Weight of the body on the surface of the earth. Therefore, weight of the body on the planet is equal to 4/7 into. So weight of the body on the earth, what did they give? It is 700 gram weight. It is a 700 gram weight. 700 gram weight. So numerator, this will get cancelled 100 times. Therefore, we'll get that 4 into 100, 400 gram, 400 gram weight. We'll get 400 gram weight. Like this, 400 gram weight. The mass and the diameter of the planets have twice the value of the corresponding parameters of the acceleration due to gravity on the surface of the planet. The mass and diameter in terms of the radius, or in terms of the mass, we have take the formula. The mass and diameter of the planet have twice the value of the corresponding parameters of the Earth. Acceleration due to gravity on the surface of the planet is acceleration due to gravity on the surface of the planet is mass and diameter of planet, they are given. Mass of the planet is twice, 2 times the mass of the Earth, 2 times the mass of the Earth, and corresponding diameter of the planet, D for diameter. Diameter of the planet is equal to 2 times the diameter of the Earth. It's nothing but radius of the planet. Radius of the planet is 2 times the radius of the Earth. Radius of the planet is 2 times the radius of the Earth. That will take. Acceleration due to gravity on the surface of the planet. Acceleration due to gravity is to be calculated on surface of the planet. So G is equal to Gm divided by R square. From this, G is proportional to M divided by R square. Then Gp divided by Ge is equal to Mp divided by Me into Re square divided by Rp square. Like this we will write. And substituting, Gp by Ge is equal to mass of the planet is 2 times the mass of the Earth divided by mass of the Earth. Radius of the Earth is Re square, but radius of the planet is 2 times the radius of the Earth. That will be 4Re square. I'm squaring it. 4Re square. Re square gets cancelled. Me get cancelled. 2 that cancel in 4 2 times. Okay. Then Gp is equal, Gp by Ge is equal to 1 by 2. Then Gp is equal to, I'm sending this Ge to right side. Gp is equal to Ge divided by 2. From there, Gp is equal to 9.8 divided by 2. 9.8 by 2 means what? 4.9. That will be equal to 4.9 meters per second square. 4.9 meters per second square. This is the acceleration due to gravity. Okay. Next problem. As we go from the equator to the poles, the value of G that increases. Acceleration due to gravity at the equator and poles we have discussed. Let us suppose Earth is not exactly a sphere. It is flattened at the poles and bulged at the equator. This is at equator. At the equator, acceleration due to gravity, G it is 9.78 meter per second square. And at the poles, acceleration due to gravity, at the poles, whenever we take 9.83 meter per second square. So if you move from the equator to the poles, acceleration due to gravity that increases. The value of G at a particular point is 9.8 meters per second square. Suppose the earth is suddenly shrinks uniformly to half of its present size without losing any mass. The value of acceleration due to gravity at the same point is the value of acceleration due to gravity at the same point will be. This is the value of acceleration due to gravity at a particular point is 9.8 meters per second square. Suppose the earth is suddenly shrinks uniformly half of its present size without losing any mass. Without losing any mass, then the value of G, suppose G at particular point is, okay, particular point they told it. Particular point means a particular point, if you take that, mass is changing. Mass is not changing. A particular point is there. This particular point is, let us suppose, at a distance smaller from that, a particular point P is that. If the mass, without changing the mass and without changing this distance from the center to that point P, if it is same, then same acceleration gravity will be there. Acceleration due to gravity does not change. So what is the condition here? Generally, we'll say that it decreases. But here, according to given condition, the value of acceleration due to gravity at a particular point is 9.8 meters per second square that they told. At a particular point, let us suppose this is Earth. On the Earth at a particular point, acceleration due to gravity. At this point, if you want acceleration due to gravity, 9.8 meters per second square, which is at a distance smaller from the surface of from the center of the Earth. So without changing that, without disturbing that distance between, without disturbing this this one, what is happened? Suppose suddenly, suppose the Earth suddenly shrinks uniformly to half of the present size. It is reduced to like this, without changing mass and without disturbing this distance r. The change is place. A change takes place. That's why acceleration due to gravity it does not change. So as mass and as mass and distance are constants, acceleration due to gravity G is also constant. Constant means what? G is equal to 9.8 meters per second square. That is how much it is there. 9.8 meters per second square is there. That will be 9.8 meters per second square. Next. The mass of the Earth is 81 times that of the Moon, and radius of the Earth is 3.5 times the Moon. The ratio of the acceleration due to gravity on the surface of the Moon is, actually acceleration due to gravity on the surface of the Moon is 1/6 of the surface of the Earth. 1/6 of the surface of the Earth. What is given? That mass of the Earth is 81 times. Mass of the Earth is 81 times the mass of the Moon. Mass of the Earth is 81 times the mass of the Moon. Mass of the Moon. And radius of the Earth is 3.5 times the radius of the Moon. Then ratio of the acceleration due to gravity at surface of Moon to that surface of the Earth. So ratio of the acceleration due to gravity on the surface of the Moon divided by acceleration due to gravity on the surface of the Earth. So then what is the formula? G is proportional to m divided by r square. So then G1 by G2, then G1 by G2 is equal to M1 by M2 into M1 by M2. That means I am taking it is in terms of moon. Acceleration due to gravity on the moon divided by acceleration due to gravity on the earth is equal to mass of the moon divided by mass of the earth into RE square divided by RP square. R moon, RM moon, R for moon. R moon we have taken, R moon square. So G moon by GE is equal to mass of the moon divided by mass of the earth into RE square, RE square divided by RM square. Then this ratio we have to calculate. Mass of the moon is mass of the moon only. Mass of the earth is 81 times. 81 times the mass of the moon into RE, radius of the earth is 3.5. 3.5 whole square into RE square. No, it is 3.5 times the radius of the moon. This is RE is equal to 3.5 whole square into R moon square divided by R moon square. R moon get cancelled. Mass of the moon get cancelled and radius of this moon also gets cancelled. So 35 are 12.25 it is. That is equal to acceleration due to gravity on the moon by acceleration due to gravity on the earth is equal to, what is this? 3 3s are 9. 12.25 divided by 81. 12.25 divided by 81. So on simplifying this, we will get 0.15. On simplifying, we will get like this. Next. If the earth suddenly shrinks without changing mass to half of the present situation, without changing mass, it's a present. Previous problem, they have given a particular point, but here radius is changing. If radius of the earth or the planet, if it changes, then acceleration due to gravity changes. G is equal to GM divided by R square. If mass changes or radius changes, if mass or radius, if they change, then acceleration due to gravity also changes. But what is given in the previous problem, particular point is there. The particular point is at a distance small r from the center, particular point P. So mass of the earth means without changing mass of the earth, that it is shrinks to that. That's why there is no change, 9.8 meters per second square only. But here what is given? Here it is given that if the earth is suddenly shrinks without changing mass, clearly they mentioned that to half of the present radius they told. To half of the present radius they told it. Means what? Radius is reducing, mass remains constant. Then acceleration due to gravity depends upon square of the radius. Then as radius is reduced to 1/2 times, acceleration due to gravity will be increased to 4 times. Then how to take it? G1 is taken as G. G1 is taken as G. R1 is taken as R. Then G2 is how much? If radius R2 is half of the initial radius. Therefore, G is equal to Gm by R square. Then G is inversely proportional to R square. G1 divided by G2 is equal to R2 square by 4 into R2 square means what? R by 2 whole square into R square. Both the numerator and denominator R square gets cancelled. That is equal to G1 divided by G2 is equal to 1 by 4. Therefore, G2 is equal to 4 times of the G1. G2 is equal to 4 times of the G1. Nothing but 4 times of G, right? Next, diameters of the two planets. The diameters of the planets are in the ratio 4:1 and their mean densities are in the ratio 1:2. The acceleration due to gravity of the planets. The diameters are in the ratio means what? It is radius also. As it is a comparison, radius also. So diameters are in the same ratio, nothing but radius also in the same ratio. R1 by R2 is equal to 4:1. Then densities ratio, ρ1 divided by ρ2 is equal to 1:2. Radius density of the diameter is nothing but diameter is radius is directly proportional to diameter. Radius is half of diameter, so radius is directly proportional to diameter. Instead of writing diameters, I have taken R1, R2. R1 by R2 is equal to 4 by 1. From this, we will write then acceleration due to gravity. G is inversely proportional. Sorry, in terms of density, G is equal to 4 by 3rd pi R G into rho. Therefore, acceleration due to gravity, G is proportional to R into rho. G is proportional to R into rho. Therefore, G1 by G2 is equal to R1 by R2 into ρ1 divided by ρ2. Therefore, G1 divided by G2 is equal to G1 by G2 is equal to R1 by R2. It's given as a ratio 4:1. And the densities ratio ρ1 by ρ2, how much it is given? To 1:2. Both in numerator and these two get cancelled in 4 2 times. Therefore, we will get G1 divided by G2 is equal to 2:1. G1 by G2 is equal to 2:1. Therefore, C option is correct. Okay, next. This is at what altitude in meters will be the acceleration due to gravity is 25% of the Earth's surface. At what altitude in meters will the acceleration due to gravity is 25% of the percentage of that at the surface? Then at what altitude it will be there? Means what height is to be calculated. Acceleration due to gravity, how much it will be? 25%. Acceleration due to gravity is G is equal to 25%. It will be there. So it will be equal to 25% of that of Earth's surface. At what altitude? Okay, only 25% of that at height. GH is equal to 25% of the G it is. So GH is equal to 25% of the G. 25 divided by 100 we will take. 25 divided by 100 g. So these 25 that cancel in 100 how many times? 4 times. Therefore, acceleration due to gravity at a height is g by 4 times. Acceleration due to gravity at height is g by 4 times. Then when we take that, for if RH is much more than that of or equal to that of the radius, then we will take that g is equal to the relation between the acceleration gravity g and radius. So g is equal to or gh by so gh divided by g is equal to r divided by r plus h whole square. This gh by g. Gh is equal to g by 4. Gh is equal to g divided by 4 into g. That is equal to. This is a radius r by r plus h. It is r divided by r plus h. So from this we will write is equal to r by r plus h whole square. Right. G and g gets cancelled. Then r divided by r plus h whole square is equal to 1 by 4. On sending this to right side, it will be r divided by r plus h is equal to 1 by square root of 4. It will be equal to 1 by 2. And on cross multiplication, we will get r plus h is equal to 2r. Then h is equal to, on sending this r to right side, we'll get to h is equal to 2r minus h. Therefore, h is equal to r. H is equal to r. If the earth stands still, what will be its effect or man's weight? If the earth rotational speed of the earth increases, weight of the man that decreases. If the earth rotational speed that decreases, weight of the man increases. When the earth suddenly when the earth stops, weight of the person or weight of the man on the earth increases. When the earth stops suddenly, centrifugal force on the man becomes 0. So its effective weight increases. Centrifugal force on the man becomes 0. So the effective weight of the man that increases. Next problem. This is important problem. This is for infinite series. That will say geometric progress. GP will say that. What is the geometric progress? GP, called as geometric progress. For infinite terms, a divided by 1 minus r. What is that? Let us suppose 1 plus 1 by 2 plus 1 by 4. Like that, if it is there, first one is, this is the series. First one, a is taken as a 1. Okay. R is taken as the second term. R is taken as a 1 by 2. Like this, we have to add this. So S infinite is equal to 1 divided by 1 minus 1 divided by R. 1 divided by 2. Like this, we will calculate. An infinite number of point masses, each equal to m, are placed at x is equal to 1, x is equal to 2 meters, x is equal to 4 meters, x is equal to 8 meters. What is the total gravitational force? See, the diagram is like this. Mass is there. From that origin of the coordinate system, at 1 meter distance, mass m is placed. At 2 meters distance, a mass m is placed. At 4 meters distance, a mass m is placed. And at like so on, at 8 meter distance, a mass is placed. So like that, we will take. Then to calculate it, what is the gravitational potential they have asked? what is the gravitational potential? So gravitational potential V is equal to minus Gm divided by R1 plus Gm divided by R2, Gm divided by R2 plus Gm divided by R3. Like this we will take. Like this we will take. Then V is equal to minus Gm if I take common. What is there? 1 by R1 plus 1 by R2 plus 1 divided by R3 plus so on. Plus so on. That we will take. So then V is equal to minus Gm into this is what is the distance? Distance is taken as 1 by 1 meter, 1 by 2 meters, 1 by 4 meters, 1 by 8 meters. That we have to take. Then distances are taken as 1 by 1 meter, 1 by 2 meters, 1 by 4 meters, like that. It will be 1 by 1, 1 by 2, 1 by 4, so on. From this geometric progress, when we take that, this is the first term A, second term is taken as R. For the geometry progress, we'll take that geometry progress. A is taken as a 1 and R is taken as a 1 by 2, right? Then S infinite is equal to A divided by 1 minus R. A divided by 1 minus R. Therefore, S infinite whenever we take, A is equal to 1 divided by 1 minus R. R is how much? 1 by 2. 1 minus 1 by 2, this is 1 by 2. 1 by 1 minus 1 by 2, 1 by 2 only. It comes to numerator. Therefore, S infinite is equal to 2. S infinite is equal to 2. Therefore, V is equal to minus Gm into this full term will be equal to 2. So V is equal to minus 2 Gm. See, this is the solution. Next one. Energy required to move a body of mass m from an orbit of radius 2r to 3r. Energy required to move a body of mass small m from an orbit of mass 2r to 3r. 2r to 3r, we have to move it. Then what is the energy? So the work, what is that energy required? Work energy is required is nothing but work done. Work done will be equal to change in potential. Work done will be equal to change in potential. Work done is equal to final potential minus initial potential will take. Final potential minus initial potential. Okay. So work done is nothing but the difference in it's nothing but potential energy. Work done will be equal to potential energy. So we have to move it from the orbit of radius 2r to 3r. So change in potential energy will be equal to work done. There potential energy in the first case, if you take that U1, if I take U1 is equal to minus G capital M small m divided by distance, so R1. What is the R1? R1 is equal to R. So U2, if you take that, U2 is equal to minus G capital M small m divided by R2. R2 is equal to what? 3R we will take. R1 is equal to 2R, R2 is equal to 3R. Then U2 is equal to minus G capital M small m divided by R2. So then work done will be equal to minus G capital M small m minus G capital M small m divided by R2 minus of minus becomes plus. G capital M small m divided by R1. Then work done W is equal to minus G capital M small m divided by R2. R2 is not mentioned. R2 is equal to how much we have to write? R2 is equal to 3R plus G capital M small m divided by 2R. That is equal to 6R if I take LCM minus 2GM plus 3GM minus 2GMM plus 3GMM. That will be GMM divided by 6R. Okay. So next, I'm going to start that next chapter. Mechanical properties of fluids. Mechanical properties of fluids. Atmospheric pressure, whenever we take, one atmospheric pressure is equal to 1.013 into 10 power 5 pascals. This is the atmospheric pressure. 1.013 into 10 power 5 pascals. This is the expression for the atmospheric pressure. One atmospheric pressure. Then pressure is equal to force per unit area. Pressure is equal to force per unit area. How much force acting per unit area is called as the pressure. Right. Whenever we take that surface on the surface of the liquid, if we take that it is a surface of the liquid, on the surface of the liquid, then pressure is nothing but atmospheric pressure. When we take the body into depth of the liquid, at the point A, atmospheric pressure is there. At the point B, the pressure is taken as atmospheric pressure plus the pressure that is arised. The pressure that is arised due to that liquid column is called as that H height is there. Then the pressure has arisen due to the liquid column, will say that pressure at the point P is atmospheric pressure plus gauge pressure rho GH. H for height of the liquid. So pressure at the point B is equal to atmospheric pressure plus gauge pressure. Rho GH is called as the gauge pressure. Rho GH is called as the gauge pressure. That is a pressure arises due to that liquid column, will say that. Let us suppose density is equal to mass by volume. Density is equal to mass divided by volume. And from this we will write that volume is equal to mass by density also. We may write. What we are doing here? Two liquids are there. This is one liquid of mass M1, and density of the liquid is given as density is taken as rho 1. Other liquid of mass M2. Mass M2 and density rho 2. They are mixed. They are mixed. Then what is the common mass? Common mass or density. Whenever we mix that density is called as that new density. How much it is there? New density. How much new density will be there? That is. So rho is equal to m1 plus m2 plus m2 into rho 1 rho 2 divided by rho 1 rho 2 divided by m1 rho 2 plus m2 rho 1. m1 rho 2 plus m2 rho 1. This is rho is equal to m1 plus m2 into rho 1 rho 2 by m1 rho 2 plus m2 rho 1. This is right. If the liquids of the volumes, if you take the volume of the liquid is taken as V1, the volume of this liquid is taken as V2, then V is the common volume. In terms of volume, when we take that, in terms of volume, whenever we take that, rho is equal to in terms of density and volume, V1 rho 1 plus V2 rho 2 divided by V1 plus V2 plus V1 plus V2. This is. So here, if masses are same, M1 is equal to M2, then what will write? Rho is equal to rho 1 rho 2 divided by rho 1 plus rho 2. Here, rho is equal to V1 rho 1 plus V2 rho 2 divided by V1 plus V2. If volumes are same, V1 is equal to V2. Then what will write that? Rho 1 plus rho 2 divided by 2. CET problem is there from these formulas. Fine. Next. Whenever we take that, let us suppose it is a liquid. In the liquid, whatever it may be that, the point B, it is at the point A. At the point A, pressure is taken as atmospheric pressure. If I take a point B, which is at a depth H, the pressure already we discussed at the point B. What is the pressure at the point B? PB is equal to pressure at the point A plus gauge pressure, rho GH will take that. Okay, if I take the other point here, see the point C. Why above the point C also the liquid column is same. That's why at the point B and at the point C, same pressure will be there. Same pressure will be there at the point B and at point C. Or whenever we take, it is a pipe. If the bottom is same for all the different shapes of the pipes, if the bottom is same for the, even though they have the different shapes, the bottom, if I take it as same, the liquid rise will be there. Then liquid rise will be same. Up to the same level rise of liquid will be there. If the bottom is same for all of them, liquid rise will be same. So based on this, the height is taken as h. For this also height of the liquid is taken as h. For this also height of h. All the 3 points at this point or at this point or at this point. So pressure will be same. Pressure at A, first point, second point, third. So P1 is equal to P2 is equal to P3 we will take. P1 is equal to P2 plus P3 we will take. So this is called gauge pressure. That's a hydrostatic paradox. We'll say that hydrostatic paradox. Then pressure is equal to force per unit area. Pressure is equal to force per unit area. According to hydrostatic, according to these hydraulic lifts, hydraulic brakes, they works on this. This is called as Pascal's law. Whenever you take that Pascal's law, the increase in pressure, let us suppose this is there a pot, let us suppose if we consider, and the top of the pot, the liquid atmospheric pressure is there on the liquid surface. On top of the plate, the liquid surface, atmospheric pressure is there. So this will be equally transmitted to all the points. The atmospheric pressure will be equally distributed from all the points. So liquid comes like this, liquid comes like this, liquid comes like this. So this pressure, atmospheric pressure will be equally distributed among all these points. That is called the Pascal's law. So according to Pascal's law, Brahmas means Brahma's work, Brahma's press, Brahma's press are hydraulic brakes and hydraulic engines. They will work on the Pascal's law. Next, according to Archimedes, if a body is completely or partially immersed in a fluid, then it will be displaced by an upthrust or upward force will be there. Archimedes principle. Let us suppose this is that if the body is completely or partially immersed in a fluid, then it will be experienced by upthrust, that will say force of buoyancy, or buoyant force will say that. Force of buoyancy or buoyant force, that will say. So this is a same. This will be same. Buoyant force, that is equal to, it will remove the volume of the liquid, equal volume it will apply, it will occupy. So next one is equation of continuity. Equation of continuity. Equation of continuity states that, let us suppose different area of cross section of the pipes I have taken. Different area of cross section of the pipes I have taken. This is A1. This is A2. Pressure at this point is taken as P1. Pressure at this point is taken as P2. Okay. Equation of continuity. A1 V1 is equal to A2 V2. A1 V1 is equal to A2 V2. Otherwise, pi R1 square V1 is equal to pi R2 square V2. Like this, we take. Okay, I'm going to stop the class here. Now I have to attend for other class. We'll see that remaining synopsis and problems in tomorrow's class. Thank you.
Thank you, sir.